So now what we want to do is we want to talk about set equality a little bit more. So A equals B. What was the definition of A equals B? If you look back at that table for all X and U, it corresponded to a biconditional statement. X is in A if and only if X is in B. But remember I said biconditional statements, which are these ones right here, they're made up of two conditional statements. So I could think of this as saying for all X and U, what it really means is if X is in A, then X is in B, and if X is in B, then X is in A. But if you look, these correspond to the conditional statement that you see in the definition of a subset. So really, if A is equal to B, then this says that A is a subset of B, and B, so this one over here says B is a subset of A. So if I want to show that two sets are equal, I have to show these two things as well. I have to show A is a subset of B and B is a subset of A. So let's look at an example here. Let's take the following. Let's say the set A is going to be the set X's in Z, such that there exists a K in Z, such that X equals 3K minus 1, and B is going to be the set Y in Z, such that there exists an N in Z, so that Y equals 6N plus 5. So what I want to know is, are these sets equal? So are sets A and B equal? Well, it might help if we write out some of the elements in these sets. So let's start with A. And what I'm going to do is I'm going to pick values for K. And that will give me elements in my set. Now these are infinite sets, so I'm not going to be able to write down all the elements. Let's say I plug in -2 for K. And that'll give me my first element of A. So if I plug in -2 for K, you'll get -7 for X. If I plug in -1 for K, what will I get? I'll get -4 for X. 0 for K, you'll get -1. Let's plug in 1 and 2. So if I plug in 1, I'll get the number 2 for X. If I plug in 2 for K, I'll get the number 5, and so forth. Okay, so I wrote out a few elements of this set A. Let's also write out a few elements of this set B. So here, what I need to do is I need to pick values for N. So for N, let's start with -2. If you plug in -2, you're going to get -7. If you plug in -1 for N, you'll get -1. If I plug in 0 for N, you'll get 5. 1 for N, you'll get 11, and so forth. And so does it look like these sets are equal? Well, these numbers are only going to increase and get larger. All right, so if I look, B has -7 in it, and so does A. B has -1, so does A. B has 5, and so does A. So it looks like all the elements in B are also in A, but I have some elements in A that were missing in B. So in particular, what I can say is that there was an X, there was an integer that was in A, but not in B. There are many, but one of them, so for example, -4, that was in A, but it wasn't in B. So I can now say that these two sets are not equal, because if they were equal, they have to have the exact same elements in them. But I did notice that all the elements in B were in A. So, however, the elements of B are in A. So now what I want us to do is I want us to prove that. So let's prove, I want us to prove now that B is a subset of A. And remember our definition of a subset, I need to show that if X is in B, then X is in A. Right, so this is the part right here that I need to prove. So let's write an outline of this proof. So what would the start of the proof be? You would start by saying X is in B. And what is my conclusion? Where's my end of my proof? I need to conclude that X is in A. So the end, down here, the end will be X is in A. Well, what does it mean to be in A? Go back to the definition of the set A. It means I can write X as 3 times K minus 1 for some integer K. Okay, so that's where I've got to get to, but let's go back to our start now. If X is in B, well then I know by the definition of B, X is 6n plus 5 for some integer n and z. And then look where I need to go to. I need a -1 here at the end, so I'm going to modify this equation. I'm going to rewrite this plus 5 as 6 minus 1. And then if I look here, I need 3 times a number, so I'm going to factor a 3 out of 6n. That'll leave me with 2n. And now I'm going to separate off this -1 to the n as x equals 3 times 2n plus 6, and then the -1 off to the side. So all I need to do is pull out a 3 out of these two terms right here. Pull out a 3. It'll be 2n plus 2 minus 1. And so I should let k be 2n plus 2. And we know that k is an integer because it's a sum and difference of integers. So another way to say that is because of the closure of addition and multiplication of integers. And so now we've kind of filled in the gaps in this proof. We just got to write up a formal proof for this statement. So you should write up a paragraph proof of this outline here.